When we consider a closed interval of a continuous function, there is an absolute maximum or absolute minimum contained in that closed interval. What about the case when the domain is not closed? Well, as long as the function has only one relative extreme value, then it must be an absolute extreme value. This intuitive fact is known as the unique extremum theorem. It says that if a continuous function f has exactly one relative minimum on an interval, then that value is an absolute minimum. If f has exactly one relative maximum, then it is an absolute maximum. This simple and intuitive theorem is important in applications. For example, suppose the math department wants to produce a textbook for a new math course. Each page must have 72 square inches of printed material and must be bordered by half-inch margins on each side and 1-inch margins on the top and bottom, as in the diagram. To minimize costs, we need the pages to be made as small as possible. What are the dimensions of the page that satisfy the requirements? Well, the area of the printed region is length times height, which gives us 72. The area of the page to be minimized is A equals L plus 1 times H plus 2. Then using the first equation, we solve for one of the variables, L or H, it does not matter which one, and then we substitute it into the second equation so that A is a function of only one of the variables. In this case, A is a function of the height, H. We'll simplify this, and now we'll take the derivative. We get A prime equals negative 144 H to the power of negative 2 plus 1. To minimize this, we need to find the critical points. So we set this equal to 0, and we're going to solve for H. Solving for H, we get H equals 12. Now we need to use the second derivative test or first derivative test to classify this critical point. Let's use the second derivative test. The second derivative, A double prime, equals 288 times H to the power of negative 3. Evaluating this at H equals 12 gives us a positive answer, which means that H equals 12 is a relative minimum by the second derivative test. Since it's the only relative minimum on the open interval from 0 to infinity, then by the unique extremum theorem, it is also an absolute minimum. Then the length L is equal to 6. The area of the page is A equals 6 plus 1 by 12 plus 2, so 7 by 14.